Good afternoon, Miss. Krishnendu, Miss.
Good afternoon, sir. Am I audible?
Yes, actually. It's
Okay,
audible.
okay, sir. Yeah.
Shnendu ma'am, shall we start?
Sure, ma'am, sure. So, may I share the presentation, ma'am?
Okay, we will start with an introduction.
Okay.
Okay, welcome back to session 6 of our online FDP, organized by Department of Electronics and Communication Engineering, Jyoti Engineering College. It is my pleasure to introduce our resource person, Dr. Krishnendu SP. Dr. Krishnendu SP is an assistant professor at the Indian Institute of Information Technology, Kottayam, with research expertise in next generation intelligent networks, artificial intelligence, geospatial data integration, and advanced analytics. Her works bridges the gap between AI-driven network intelligence and real-world communication system designing, positioning her as a promising researcher in the domain of smart and adaptive communication networks. She brings both academic rigor and applied insight into the rapidly evolving space of next generation network architectures. We are honored to invite Dr. Krishnendu SP to deliver an online session on next generation intelligent networks, integrating AI, geospatial data, and analytics at our faculty development program. Thank you, Ms. Welcome to session 6 of our FDP. Welcome, ma'am.
Thank you, ma'am. Thank you so much for that invite and my introduction. So, I'll be sharing my screen. I hope this is visible, ma'am.
Yes, ma'am.
Okay. Okay. So, I hope we can start. So, good afternoon, everyone. It is actually a pleasure to be here today to interact with all of you on a topic that is actually rapidly transforming the way that we think about communication systems, or you can think about a smart infrastructure and a digital ecosystem. Usually, when we hear about the word networks, most of us immediately think of internet connectivity, right? Or something like a routers or the switches or mobile communication towers or you may be thinking about maybe perhaps Wi-Fi networks. Okay, so traditionally the networks they have been viewed as communication pipelines whose primary job was to move data from one point to another. That is our way of understanding the network. So however, that is actually not the real case. As the world around us has changed dramatically, at least we should know how exactly, or how, or which all perspective, from which all perspective we have to think about the network. So today, actually we are surrounded by maybe billions of connected devices, you can say. Our smartphones, they're continuously generate the location information. So if your location information is on, so it is second to second, it is generating where you are, or the vehicles that is communicating with the infrastructure. So those who using the vehicles with a sim inserted in it, the location is being tracked by an app. Similarly, a sensor monitors, so that continuously communicates with the smart city infrastructure, or the industries, or even the farms, or maybe the environmental condition, the weather condition. Everything in real time is in a continuous communication to the infrastructure. So in such an environment, merely transferring data is not actually enough, okay, when you are thinking about a network. So that is our point of discussion. So modern networks are expected to understand actually what is happening around them. Not only that, but also to learn from the data. What is the data they are getting? What to be done with that data, or to with that data predict the future events, and make intelligent decisions. Okay, with a minimal human interventions that is expected from the modern networks. So this is where actually the artificial intelligence, geospatial intelligence, and the analytics of these data are coming together to help you out. So AI, or artificial intelligence, in this platform of, or in the from the foundation of communication or the networks, helps the systems to learn and make decisions. Okay. Then regarding the geospatial intelligence, it adds the critical dimension of location. Okay, so geospatial intelligence, that's how it is being said. It is adding the information or dimensions of your location and the spatial context. So what about the analytics perspective? So analytics transform this massive amount of this raw data or the information into an actionable insight. Okay, so when these three domains converge, then only our network is becoming far more than a communication system. So they become intelligent ecosystem capable of sensing, understanding, and predicting and responding to the needs. Okay, so that is how the actual networks are communicating or being used in today's intelligent world. So throughout this session, what I have planned is to explore how these technologies are shaping the next generation of intelligent networks. Okay, so how they are influencing the areas such as transportation, where I'm working a lot into it, and my core area of research, as ma'am said, transportation and smart cities. And then we will look into few disaster management case studies, and then the future communication infrastructure. Okay, so with that context, I hope we can directly jump into the session of how that communication is happening, or the how the next generation intelligent networks is behaving to evolve this entire maybe the world, we can say. Okay, so to appreciate where we are heading, okay, so we are heading towards the next generation communication, so it is important to understand where we started. That is why the importance of history is coming into. So if we are looking at the early generation of communication networks, okay, so they primarily focused on the connectivity, or at least we can say that their primary objective was the connectivity. Okay, so the network's responsibility was actually simple when they have started it, to ensure the data that could be moved from one device to another. That was their primary objective. So whenever a problem occurred, what happened? So moving our data from one device to another, something happened. So how we have solved it? The human interventions. The human administrator will be stepping in and he will be solving the problem. So if there was a congestion, who will be involving it? An engineer who is well versed with that particular domain will be investigating what has happened and he will be resolving it. And if a device failed, so it is the headache of the administrator. So he will be manually diagnosing and he will be repairing it. So in other words, these networks were largely reactive. Okay, so they responded to problems only after those problems occurred. So as communication demands increased, so our problems also increased. So this approach where every time we will be going there and finding out what is the problem and how it occurred and solving it became difficult to sustain. That is what actually happened with the communication system. So this need, or this need of identifying the problems or anticipating the problems led to the emergence of software defined networking. And maybe you can say that the network virtualization technologies. Okay, so now actually we are in the platform where we are actually stepping into the 6G. We are thinking like we are not even started the usage of 5G. Then is it the time that we are stepping into 6G? Yes. So with the arrival of 5G, every easiness of solution has started. So this time we are actually in that transition stage from 5G to 6G. Okay, so when we have reached the 5G, what happened? When we reached the 5G, or at least when 5G has arrived into the network communication, the networks became more programmable or flexible and even scalable. Okay, so that was uh, uh, that was the maybe you can say it as an add-on when you have reached the 5G level. Okay, so for the first time, networks could dynamically allocate the resources, support millions of connected devices, and provide ultra low latency services. So however, these advancements brought new challenges. When you are allocating more and more devices, obviously you are going to get into some problem. So imagine managing a network serving millions of users, or you think about billions of IT devices are connected into your networks. Something like we are anticipating driverless cars, right? So you think about that scenario, autonomous vehicles, no drivers, they are continuously communicating. So how will you manage such a networks? Actually, the smart factories, every workers, everything has been changed to our robot or robot arms kind of things, or the maybe a critical healthcare applications. So when at least two of these cases, at least the IoT devices and the smart factories, when these things coming together, the networks are becoming even complex. So the complexity becomes overwhelming here in such cases. So this is where we now entering into the era of next generation intelligent networks. So that can only be done, or that can be done easily when we are completely shifted to 6G. So now, as I said, we are in the transformation stage. So these networks are proactive. Okay, so rather than it being it said as reactive. So instead of waiting for failures, they predict them. Even in the large machineries that is using in healthcare services, they are investing a lot into the machineries, huge machineries. So what happens if a failure is happening and the machine is not even working? So what about their investment? So they are not accepting, they will not be welcomed by that hospital management to the failure of a system. So everywhere what we are doing is we should anticipate, or we should predict the failures, or we should identify the problems even before it is happening. Okay, instead of waiting for the failures, we should be able to predict them. Instead of relying entirely on human operators, they automate the decision making. Instead of treating every user identically, they understand the context, locations, and application requirements, and then you identify the problem and then you solve it. Then you do some automation to solve the problem. Okay, so this is what we are anticipating from the next generation communication networks. Okay, so think of a difference between a traditional traffic policeman standing at a busy intersection as a smart traffic management system. Okay, so what is the difference? So what is the difficulty there? If we are automating that and we are truly bringing that smart traffic management system, without that traffic policeman, it will be able to continuously monitor the traffic patterns. Okay, so it can predict the congestion and can automatically adjust the signal timings. That happens. Okay, so that will be more acceptable from the people. Okay, so that difference, it perfectly, you can say it as captures the transition from connectivity to intelligence. Okay, so now the obvious question is, why are we suddenly moving in this direction? What are the factors that are forcing this transformation? Why we are moving into a next generation intelligent networks? Okay, so there are several reasons actually why we are moving into a intelligent networks, or why these intelligent networks are becoming a necessity rather than a luxury. Actually, it is not a luxury. Luxury is something that you can imagine what is a luxury, but actually having a next generation intelligent network is not at all a luxury, at least at today's world. Okay, so this through this session, I hope you will explore the growth of connected devices. Okay, so the connectivity among the devices extends far beyond our laptops and maybe you can say the smartphones. Okay, so we have a smartwatch, maybe a fitness trackers, the connected vehicles, maybe the surveillance cameras, the industry sensors, the agricultural monitoring systems, and countless IoT devices that are generating a continuous streams of data. Okay, so for every one of these devices, they places demands on the underlying network. So how that communication happens? Through the network only, right? So each of these devices have their own demands from by accessing the network. So the second reason is the need of real-time decision making. So consider an autonomous vehicle approaching an intersection. So the vehicle cannot afford to wait several seconds or a long period of time for a response from the distant server. So it has to be an edge device. The decision has to be taken at that point of time by that device who is responsible for decision making of that particular relationship. So that communication delay should not happen. So it needs an immediate information and an immediate decision. Okay, so that is a second reason why we need a next generation intelligent networks. Similarly, you can think about a healthcare application. So the remote surgeries. Okay, so the expert in a particular domain, or he is residing in some other country, you can assume like he may not be able to travel, or he won't be reaching within the time of or at least that surgery is scheduled in as a emergency case. Okay, so it was a sudden decision. So what happens? So the surgery happens as a remote surgery. So the expert will be helping the senior surgeon from a faraway position. So what happens then? It requires an extremely low latency. Right. So similar case in case of disaster management. You might be remembering the case when Kerala faced that flood in 2018. Okay, so delays in communication can directly affect the human lives. Okay, so third factor why we need such an intelligent network communication is the increasing reliance of data-driven infrastructure. So the organizations, they no longer want to simplify the or they no longer want to simply collect the data, you can say. They don't need that simplification of the process. The data needs to be collected to form some insights. They want the predictions, they want the recommendations, and they want the system capable of identifying the risks before they become problems. Okay, so that is another reason why we need such an intelligent networks or next generation intelligent networks. And another major factor you can assume is maybe in case of the need of autonomous operations. Okay, so as the network continue to grow in size and the complexity, so once the size is becoming larger, the complexity obviously will be higher. Okay, so the manual monitoring and managing of these entire network will become increasingly, maybe you can say, um, near to an impractical kind of thing. So human operators, they can't simply track millions of events occurring every second. Okay, so they need some helping hand. So you consider it as a helping hand rather than considering it as a luxury. Okay, so another or maybe the final reason why we need is an important factor is that location intelligence. Okay, so it is not like we can track each and everyone's locations. Almost every event occurs somewhere. Okay, so the traffic congestion occurs at one location. So the network outage occurs at another location. The flood is occurring at some other locations. So last week that earthquake, it happened at some other location. So users move through locations. So location provides the context. So if you want to have some inferences, if you want to analyze, and if you want to predict something, you need the locations. Okay, so without the location, data tells only part of the story. So with the location, your data will be very meaningful and an actionable thing. So this brings us to the very important idea that serves as the foundation of this entire session, that is uh, the convergence of trifecta. Okay, so if we can plot an image that will be showing the entire architect or entire the convergence of these technologies, you can plot a image like this. Okay, so the central idea is that the true intelligence emerges when three powerful domains work together. It is not the duty of AI alone. It is not the duty of the geospatial data alone, and it is not the duty of the data alone. Okay, so the first domain is the artificial intelligence. So what is the job of AI? So the AI help us to learn from the data, and it enables the systems to identify the patterns. And from the patterns, they make predictions, they optimizes the resources, and they automate the decisions. For example, AI can predict a network congestion. Okay, or it can predict that or it can detect the anomalies. Okay, even in the traffic network or communication systems, or in wherever the anomalies are present, if you have trained it, it will be definitely be detecting some anomalies, and it can definitely forecast the equipment failures before they occur. So it will save you a lot of money. Okay, so the second domain we can talk about is a geospatial intelligence. So the geospatial technologies, they answer a simple but you can think about it as an extremely important question. If I am telling that an earthquake occurred, obviously the next question would be where. Okay, so the geospatial technology is responsible to answer to the question where. Where is the event occurring? Where is the problem located? Where should resources be deployed? Okay, so the location provides the context that cannot be captured by the traditional data sets alone. And the third domain is your analytics. So the analytics, they transforms the data or the raw data or the raw information. We usually call it as raw data, right? Information is more than just meaningful data. So the raw data into an actionable knowledge. So that is a duty of analytics. So it helps us to identify the trends, actually what is happening in the surroundings, and they help you to understand the relationships, and they support the informed decision making. And nowadays, with the help of XAIs, we do have an explanations for that also. So let me illustrate this with simple example that suppose you are having a network monitoring system, okay, that is predicting the congestion. So this prediction alone is useful. You are having a network monitoring system. It is predicting the congestion. Yes, it is working very good. What we are intended is what we are getting. But assume that when geospatial intelligence tells that exactly where the congestion is likely to occur, that information is very valuable, or you can say that more significant and more valuable than simply predicting that congestion will occur, congestion are occurring. Okay, so then the analytics can estimate the number of affected users once you know that geospatial information. Okay, then how many number of users will be affected and the expected impact of that congestion, and the most effective mitigation strategy that you can implement as a solution to that congestion. Okay, so together AI, geospatial intelligence, and analytics, they can create a complete decision making framework. Okay, so that is the reason I have given the title as next gen intelligence networks that are comprising of the AI, geospatial, and the analytics. Okay, so these technologies, so this convergence is what enables the next generation intelligent networks. So now that we have understood the main three, maybe you can call them as pillars So we will analyze each one of them. So first we will think about the artificial intelligence. Okay. So how it is helping and what are the capabilities of this particular pillar. So AI is actually rapidly developing or rapidly evolving kind of uh, technology that can act as the brain of your modern communication networks. Okay, so the traditional network management, so they relied heavily on the predefined rules. So for example, you assume a network administrator. Okay, so the network administrator might configure a rule that generates an alert. That is maximum they can do it, like in the traditional network management. Okay, so that will be generating an alert when the bandwidth utilization exceeds a certain threshold. Okay, so that also that in those who are using the geo, you are getting that you have used the 50 percentage of your data daily data limit, then the 90 percentage. Once that 50 is reached, we don't know how we have reached the 90 percentage. Okay, so that is happening in everyone's day-to-day life. Okay, so you are having such a your the network administrator has configured such a rule. Okay, so while such rule based systems are very useful, they become maybe increasingly inadequate as the network complexity grows. Assume every citizen of India is taking that geo SIM. Okay, so how much will be the complexity of that network? The modern networks are highly dynamic and complex. So the user behavior, it changes continuously. Okay. Similarly, the traffic patterns, if you're observing, that are fluctuating throughout the day. We can't even predict that at this particular time a traffic will be more and it will be lesser. And yes, during the very early morning and night time it was less, but nowadays it is not. So it depends on several factors. So the applications have different performance requires if you are building for different reasons or purposes. So they will be differing in their requirements. Okay, so the static rule strategy will struggle to handle such complexity. Okay, so this is where the machine learning becomes more valuable in the application perspective. Okay, so instead of being maybe you can say it as a explicitly programmed, so explicit programming for every possible situation. So machine learning system, they learn from the historical data. Okay, and continuously improve their performance. Okay, Um and another important application is cyber security. Okay, so rather than being relying solely on predefined attack signatures, so the AI systems learn normal network behavior. So when unusual pattern emerges, they can immediately flag potential threats, enabling faster detection and the responses. So few things that can be solved by AI. Okay, so AI is also transforming the resource allocation. Networks can dynamically distribute the bandwidth and prioritize the critical applications, and they can optimize the routing decision based on the real-time conditions. Okay, so the result is improved efficiency. That is what we are reaching, or that is what we are trying to achieve through the AI by incorporating AI, and to reduce the operational cost and significantly better user experience. Okay, so in essence, what I can say is that the AI enables the network to move beyond connectivity and become intelligent decision-making systems capable of prediction, adaptation, and you can say an automation. Okay. Now that we know the role of AI in modern networks, let us have a brief discussion on the very fundamental questions when we are introducing AI. Why does a network need AI? Okay, so yes, AI can do a lot of things. What is its role in networks? So after all, these networks have been functioning for decades without AI, right? So obviously what AI can do with us may be the question that networks may be asked. So the answer lies in the scale and complexity of modern communication systems. So you consider a mobile network that serves us every day. Okay, thousands of users may simultaneously stream videos. When some very like when some film stars are getting married, thousands of users are going to live stream that marriage video through the YouTube or some Netflix or some other platforms. Okay. Similarly, attending online meetings during the time of Corona, what we have done, we have delivered lectures through online platforms. Thousands of students are watching. So upload the contents to social media and play online games. So all these things needs network. So each application has different requirements. A video call requires a low latency, and a movie download requires a high bandwidth. An IoT sensor may transmit only a few bytes occasionally, and the network has to satisfy all these requirements simultaneously. So, how can we satisfy the needs of users? So, that is, the requirements of users are very unpredictable. So, this creates several challenges. The first challenge is massive device density. Okay, so with IoT, the number of connected devices has increased dramatically. Okay, and the second challenge is unpredictable traffic. Think about a cricket stadium, or a political rally, or a festival gathering. Network demands can suddenly increase by several times within a few minutes. At such situations, it happens. And the third challenge is maintaining quality of service. So different applications, they require different service levels. A delayed WhatsApp message may be acceptable. A delayed emergency communication may not be. So that is difference. This is where AI becomes valuable. So AI enables predictive traffic engineering. As you might be seeing on the right side of this particular slide, predictive traffic engineering. So what is it doing? Instead of waiting for congestion to happen, the system forecasts future traffic patterns and proactively allocates the resources. That is what is known as predictive traffic engineering. And AI also enables anomaly detection. So that rather than manually monitoring millions of events, so the machine learning algorithms continuously learn normal behavior and identify the unusual patterns. Okay, so this can help to detect the cyber attacks, maybe network intrusions, or maybe hardware failures or configuration issues. Okay, so this is where AI comes into the picture, or AI comes into the play. Another important capability of intelligent resource allocation. Okay, so how AI will be doing? So the modern network, it can dynamically assign bandwidths, computing the resources according to the user requirements and an application priorities. Okay, so think of AI as a highly experienced traffic controller who can anticipate traffic jams before they occur, and it will redirect the vehicles accordingly. Okay, so if we are not including AI, or we can simply tag it as without AI network react, with AI networks anticipate. So that is the key difference. You can say, if somebody is asking why does a network need AI? Okay, so once we uh, recognize the importance of AI, the next question is what kind of AI techniques are used in the network domain? Okay, so two particularly important approaches are reinforcement learning and federated learning. So I'm not telling that other kind of machine learning technologies are not used, but most appreciated or most used kind of AI forms are reinforcement learning and federated learning. Okay, so first let us begin with the reinforcement learning. Many of us are familiar with the supervised learning. Okay, where the models learn from labeled examples. So as we know, the reinforcement learning is different. So reinforcement learning is, you can understand it as the maze problem. Okay, or you can assume it as how an agent will be getting a reward, positive regard or positive reward and a negative reward according to what the action it is taking. Okay, so in reinforcement learning, an agent learns by interacting with the environment. It is very different from supervised learnings. Okay, so through the interaction with the environment, and it will be receiving the rewards or some penalties, or you can assume it as positive rewards and negative rewards. Let me make it more clear. Okay, think about how a child learns to ride a bicycle. At least many of us might have gone through that stage of learning to ride a bicycle. Nobody provides a mathematical model, right? Child may not understand. And that is what is the difference between the supervised learning and the reinforcement learning. No mathematical functions will be working there. So the child learns through trial and error. Okay, he or she will fall down. Yes, that is accepted. Sometimes. Okay, at the end or eventually or over time, successful actions are reinforced. The same principle applies here as well. So in the networking, a routing agent can continuously experiment with the different routing decisions. So when the performance improves, this decision is rewarded. When the performance degrades, the decision is penalized. So eventually the system learns optimal routing strategies. So this becomes particularly useful in dynamic environments where the network conditions change constantly. Okay. So that is the role of reinforcement learning in our network. So now let us discuss federated learning. So one of the biggest challenge in AI is data privacy. Okay, so traditionally the data from users is collected at the central server for model training. Okay, that is happening in all the ML or AI related tasks. So however, this collection and saving in a central server raises a privacy concern. So how will we solve this concern to some, at least to some extent? So the federated learning takes a different approach. Okay, so instead of moving the data to the model, move the model to the data. That is easy. So training occurs locally on a device, such as smartphones, edge servers, or base stations. Okay, only the learned model updates are shared. Once the model is learned, the weights are there, the pattern it has learned is there. So that will be updated and will be shared. Okay, but the learning and everything, the training happens at the edge. So the actual user data remains local. So this provides two important benefits. First one is obviously is the privacy. The privacy is improved. The second one, that is where our concern is, the communication overhead. The communication overhead is reduced in this case. I hope you are understanding the difference. Usually what happens, we are storing everything in the cloud, and once we have to train some model, we are taking the data from the cloud and we are we are training the model. It requires a lot of network bandwidth and we cannot assure the privacy. That is not happening in case of federated learning. So as future networks becomes increasingly distributed, federated learning is expected to play a major role. Okay, so together the reinforcement learning and federated learning are helping our networks to become more autonomous, maybe more adaptive and privacy preserving. So the privacy preserving is a most discussed concern in case of data privacy when you are dealing with the communication networks. Okay, I hope you understand that perspective. Okay, so at this point, let us see how AI is actually being used in a day-to-day network management. Okay, so the concept that is behind this day-to-day network management is called AI Ops, which stands for the Artificial Intelligence for IT Operations. Okay, so the modern network generates enormous volume of operational data. You can consider these data as systems logs, the network alarms, the security events, the performance matrices, the configuration records, the every logs that is related to or every records that is related to the networks. They need to be manually analyzed. Okay, in traditional network. So manually analyzing this information is near to impossible. So we can't do that. Okay, and yes, we can do that if you are providing us with enough time to do that. And if it is an emergency decision to make, doing that manually is impossible, almost impossible. So AIOps applies machine learning techniques to automate the operational tasks. So one application is automated fault detection. Okay, so instead of waiting for the user to report problems, the system continuously monitors the network behavior and it identifies the faults automatically. That is known as automated fault detection. Okay, so another application is predictive maintenance. Traditionally, maintenance is either reactive or scheduled. Scheduled shutdown time. You might have heard. Even in our institutions, it is being followed as a scheduled maintenance time. So what happens when we are incorporating AI? So AI enables a predictive approach. For example, if a router that shows a behavior similar to the device that failed in the past, okay, so the system can understand, okay, I have seen this behavior somewhere, so what should I anticipate? The system can generate an early warning that, hey there, I'm anticipating a failure from this particular device because he is showing the same symptoms as the one who have failed earlier. That is what is happening when you are incorporating AI into the networks. So this will reduce the downtime and it will improve the reliability. Okay, so the root cause analysis is another important capability of AIOps. The third point in the slide, the root cause analysis. Okay, so often a single problem triggers hundreds of alerts. So what does AI do? AI helps to identify the actual source of the problem, as we have done in programming. The error occurred, we are backtracking from where, the origin of that particular error. Okay, so AI helps you to identify the actual source of problem rather than treating each alert separately. That will take a lot of time. So once you are fixing the origin, once you are fixing the cause, it will solve other problems that is related to that. That is the attitude of AI when you are incorporating AIOps in your network management. Okay, or you can consider it as a most exciting capability of AIOps is a self-healing networks. Self-healing networks. So imagine a future network that detects a fault, diagnoses the cause, and it reroutes the traffic and it restores the services without human intervention. Actually, that is the vision of AIOps. Several telecom operators around this world are already moving towards this direction. They are doing their best to achieve this goal, self-healing networks. Okay, so as network continues to grow, the AIOps becomes essential operational framework. Okay, now we have discussed the intelligence. Now let us introduce another critical component, the geospatial dimension. Okay, so the question is, why location intelligence matters? Okay, so the most network researchers traditionally focuses on the bandwidth, latency, throughput, and reliability. So, however, there is another dimension that is equally important. That dimension is our space or our location intelligence. So every network exists in a physical environment. Yes, every network exists in a physical environment. So every user occupies a location. Every sensor is deployed somewhere. So every communication link, it spans a geographic space. So therefore, location is actually not merely additional information. It is often a deciding factor of the communication, network communication. Okay, you consider a mobile communication. So the signal quality changes depending on the terrain or depending on your location. A hill may block signal. A building may create interferences. Weather conditions may affect the communication quality. Maybe a population density varies from region to region. So nowadays you might have been seeing that advertisement. If I'm remembering it correctly, it is from Airtel, I guess. Even if you are stuck in a traffic with millions of people or with more, okay, we won't go for a million, hundreds of people using the network, you can take that online meeting from your car right from the right right away from where you are being in the held up in the traffic. The network is or their Airtel network will be taken care of those problems. You can attend that without any interferences. That is what they are promising. The new advertisement, I guess. I hope it is from Airtel. Okay, so the population density is the factor there. That particular traffic junction, the population density is very high. Okay, so all these factors have geographic characteristics. That is what I intended to tell you. So this is why your geospatial intelligence has become an increasingly important factor. So as we are moving towards the smart cities, the connected vehicles and the locations or location aware services, so understanding the spatial context is essential. Okay, so in the next few sessions or few slides, we are going to see what is GIS. Okay, so that is a simple question I can ask you. What is GIS? Or let me make it much more simpler. What is the need of GIS, Geographical Information System? Okay. Any idea what is GIS? Rather than the expansion, Geographical Information System? Okay, fine. So suppose I tell you that a network congestion has occurred. Okay, a network congestion has occurred. So is this information sufficient? Sufficient for you to understand the entire scenario? I'm telling that a network congestion has occurred. Is that sufficient? Probably not. Obvious question. The next question will be where? The location transforms information into an actionable knowledge, as we were discussing from the right from the beginning of this session. Okay, so let us consider a few examples. Suppose a telecom operator, he observes reduced network performance. Okay, if the issue is occurring at a densely populated urban area, the response may involve adding capacity. If the issue is occurring in a mountain region, the response may involve improving coverage. That is the importance of GIS. So the solution depends heavily on location. Okay, so consider a disaster management. Knowing that the flood has occurred is useful. Knowing exactly which villages, which all roads, which all hospitals, and which all communication towers are affected is far more valuable than we are guessing it. Okay, so similarly in autonomous vehicles, which are continuously using the location data to understand their environment and make safe decision. So in essence, the location provides the context. That is what we needed to know. So it answers the questions where an event is occurring and enables the intelligent system to respond appropriately. So this is why we are incorporating or why we need the location intelligence, and GIS is important. Okay, so now let's begin by thinking about some words to understand GIS in a better way. Let us think about, or I'll tell you few words that might already be familiar with. So as you can see in the slide, maps, map, apps, visualize, satellite, data, software, and analysis. Actually, these terms are building the GIS. So GIS brings them all together into one framework. The first thing we need to understand is that GIS is not just a map. Okay, so it is a comprehensive platform that combines the spatial data with the software and applications, satellite imagery, and analytical tools. Think of it as a heart of smart decision making, where we are tracking a cyclone, managing the urban traffic, or delivering the food. You might be using the Swiggy or Zomato, right? So GIS enables us to understand what is happening, where, why, and how, using all these terminologies. So you don't need to by heart what is the definition of what is GIS. If you remember this picture, that is enough. Okay, so here each component plays a role. Each component, each of these terminologies. Why do we need a map? Map is used to visualize, data to inform, apps to interact, software to analyze, and satellite to capture the earth in a real time. So these components are interconnected, forming a system that can simulate, predict, and optimize the complex spatial phenomena. So now we can say, or now we can define what is GIS. So at its core, GIS is maybe you can say as a computer based information system. It is designed to handle maybe a large amount of spatial data, data that has a location component. Okay, so this data becomes that come from many sources such as satellite surveys, GPS devices, and GIS stores, and then the GIS stores that retrieves and analyzes the modules, and they displays this information based on what we need. Okay, so it is like a super powered database, except instead of just numbers and names. So it deals with locations, patterns, and geography. Okay, so that's how powerful GIS works. So it converts data into location-based insights. Okay, it connects the data to map, integrating the location data with all types of descriptive informations. So it has many layers. If you wanted to go into in depth of the GIS, it is as shown in this figure. It has very layer of information has been stored and used in deriving a decision or deriving some or having some conclusion on the data. Okay, or to simply define the GIS, we can say as GIS system. It doesn't just store the data. Okay, so it checks the accuracy, it integrates the data from the various sources, it manipulates it, and it analyzes it, and finally it displays it in a meaningful way. Okay, that is what GIS it is doing. Okay, so we can say GIS is a computer-based information system designed to accept, store, retrieve, analyze, and display the large volumes of spatial data from multiple sources according to user-defined specifications. Okay, so for a system from a systems perspective, okay, so GIS we can call it as a database as well as a tool set, because it includes the hardware, software, data, people, the methods. So it captures data from the satellite, GPS, field surveys, and more sources. Then it stores and processes the data. Okay, a system for capturing, storing, checking, integrating, manipulating, analyzing, and displaying the data which are spatially referenced to Earth. That is what we are considering the GIS to be. Okay, now that we are understood why the location matters and what is the GIS role in putting it together, and let us now discuss how the geography actually influences the network behavior. Okay, so many times when we think about the communication networks, so we imagine something virtual and abstract. So we think about the packets or the protocols or the bandwidths and the latency. So however, networks do not exist in vacuum, that we know. Okay, so every network that exists in a physical environment. So The cellular tower has a location. A user has a location. A sensor has a location. So even a fiber optic cable follows a physical route. So because these networks are embedded in a physical space, geographical characteristics directly influences the network performance. That is what the location intelligence says. So consider a simple example. Okay. So imagine placing a cellular network or a cellular tower in an open field. Okay. So signal can travel relatively freely because it is an open field. Now imagine placing the same tower in a dense urban environment filled with high-rise buildings. Obviously, as we have discussed earlier, the buildings are going to obstruct the signal propagation, create reflections, and introduce interferences. Okay, so the same infrastructure behaves differently because the geographical context is different. This is where the geospatial data becomes important. So the modern intelligent networks that are increasingly relying on the multiple spatial data resources. So the GPS, it provides the precise location information, as we all know. Okay, so geospatial data sources are GPS, satellite imagery, LIDAR, GIS. Prior, we have already discussed what is a GIS, and indoor positioning data. Okay, so GPS provides the precise location information. Satellite imagery provides a large scale view of the environment. LIDAR provides a highly accurate three-dimensional representation of the terrain and the structure. So what does GIS do? That we know. Indoor position system provides a location awareness inside the building where the GPS may not work effectively. GPS can tell you somewhere around the proximity area. Okay, but the location, indoor positioning is different. So when these sources are combined, we can't simply rely on one or two of these. So when we might need a combinational sources, data sources, combination of these geographical data sources to achieve what we are doing. So when these sources are combined, network gains a much richer understanding of the environment in which they are operating. Okay. The key message is that the network intelligence is incomplete without a spatial intelligence. Okay. So to build an intelligent networks, we must understand not only the communication layers but also the physical world in which we are or the communications are taking place. Okay. So what is or how it is being achieved? So how we are moving towards the next generation networks and communication. Okay, so we are in the transition from 5G to 6G, so as from GIS to GeoAI. So traditionally, GIS has been used to capture, store, manage, analyze, and visualize the spatial informations. So for example, as we have discussed, GIS can help us with answer to the questions such as where are hospitals located, which roads connected to regions, which areas are vulnerable to the floodings. So this where this population density is highest. Okay, so GIS is excellent in organizing and visualizing the spatial information, and we appreciate that. However, in modern applications, we require more than visualization. That is the difference. Okay, so we increasingly want the prediction. So we want the systems that can answer the questions such as where is traffic congestion likely to occur tomorrow? I am traveling very early morning tomorrow or at this particular date. Where should I anticipate a high traffic congestion? Which area are likely to experience network overload? Which regions are at a greater risk? during extreme weather events. So this is where our AI enters the picture. That is our artificial intelligence. So AI helps in identifying the patterns hidden within the spatial data sets. That is where our Geo AI comes. Geo AI combines the GIS, AI, and analytics. It represents the next stage in the evolution of geospatial technologies. Instead of merely showing what is happening, what Geo AI is doing. Actually, Geo AI helps us to predict what will happen in the near future. Instead of simply visualizing the spatial data, it helps us to derive an intelligence from the spatial data. Okay, so this shift from descriptive system to determine what will happen in future is done by the GeoAI. So this shift from descriptive system to predictive system is one of the most significant development in modern geospatial science and in the next generation communication systems. Okay, so now let's look into some practical examples of GeoAI in action. Okay, so the first example or use case given here is smart cell tower placement. Okay, so the telecommunication providers, they invest enormous resources in deploying the communication infrastructure. You might have been seeing the mobile towers and the repeaters that are being placed to ensure the network availability. Okay, so the challenge is deciding where to place the towers for maximum coverage and efficiency. So what were happening in a traditional case? So traditionally, this process relied heavily on manual survey and engineering experience. So this is not acceptable in now today's era. Okay, so today GeoAI can analyze elevation maps and building information, maybe a population density, user mobility pattern, and historical network demand. So based on these information, it can recommend optimal tower locations. So this result is improved result. So they will help you to improve the coverage. They will help you to reduce the cost and a better service quality. Okay, so the second example given here is beam forming and mobility tracking in advanced wireless networks. Okay, in the future 5G and 66 systems, they will increasingly use intelligent beam forming technologies. So instead of broadcasting signals uniformly in all directions, the network can dynamically focus energy towards a specific uses. That was the key behind that advertisement I have discussed earlier. What they were doing, they are dynamically focusing their energy towards a specific user. So imagine a user moving through a city. GeoAI can continuously analyze the location information and adjust the communication beams accordingly. So we are already into that. That's what we have to understand. So this improves the efficiency and the signal quality. The third and particularly exciting application is the digital twins. You might have heard a lot regarding this digital twins. So what is a digital twin? A digital twin is essentially a virtual representation of real world environment. Okay, so imagine creating a virtual replica of an entire city, including the roads, buildings, communication towers, sensors, and users. So this virtual environment can be used to simulate your network updates. It will evaluate the disaster scenario, or it will test a new deployment strategies before implementing them in the real world. Okay, so that will help you to improve the service in a very, very, very better manner. So these examples illustrate how the GeoAI transforms a raw geospatial data into an actionable result or actionable intelligence. So one of the defining characteristics of intelligent systems is their ability to combine the informations from multiple sources. As we have seen, the information, location information is not in, cannot be taken enough from a GPS or from a lidar alone. Okay, so we have to combine the information taken from multiple resources or sources. This process is known as data fusion. Nowadays, in intelligent transportation systems, also it works. The density, traffic density, is being analyzed from the images taken from cameras, geographical information taken from the lidars, radars. Every source they are utilizing to analyze the traffic patterns. Okay, so this is happening in with the help of fusing the information. So what we are anticipating or what we are expecting as an output is unified situation awareness, then a better prediction can be made, a faster decision can be made. So more informed decision making can be done if you are using a real-time data fusion. The ability to fuse the data from diverse sources is one of the key enablers of the next generation intelligent networks. Now comes the convergence. So up to this point, we were discussing the three major components: AI, geospatial intelligence, and the analytics. Okay, so we have discussed them enough. So the next step is understanding how they work together within a unified framework, so as to result in a better communication system. So these sessions or in the coming sessions, we are going to look into that one. So this in practical scenarios, how we are doing that, how we are moving from concepts towards the implementation. Okay, so in practical systems, the data continuously flows from the sensors, some other devices, satellites, and the communication infrastructure. Okay, so this data is processed during the AI models and analytical techniques. Okay, so the resulting insights after the data fusion is used to support the automated actions and intelligent decision making. Okay, so this integration forms the foundation of our modern intelligent architecture. Okay, so how do all these concepts actually work together? So at the bottom, we have our data layer. This is where the data originates. The sources can be highly diverse. They can include the IoT sensors, which are monitoring the environmental conditions. It can also include a mobile device that is generating the location and usage informations. And it can also include a spatial maps that providing a geographical context. It can also include satellite systems. They are collecting large scale observations. So essentially, this layer, it represents the sensing capability of the network. Okay, so however, collecting the data alone is not useful. So these raw data has a little value unless it is being processed. Okay, or we are interpreting or we are observing what they really mean. So this brings us to the analytics and the processing layer, the second layer of your integrated or intelligent network communication. Okay, so this is the intelligence layer of your architecture. Which layer? Analytics and processing layer is your intelligence layer in the architecture. So Geo AI algorithms identify the spatial patterns. So the analytical systems are generating the insights and predictions at this particular layer. And importantly, much of this processing is now moving towards the edge of the network rather than being performed entirely in a centralized cloud environment. Okay, so all these data, finally, we are reaching to the action layer. So this is where intelligence translates into action. So the first layer is your foundation, then you have intelligence, then you have your action. The network may reroute the traffic, allocate an additional resource, adjust the communication parameters. It may deliver the localized service, or it may trigger alerts and recommendations. Based on whatever requirement that you are having, it will act accordingly, the actionable or the action layer. So the data is collected, intelligence is generated, actions are executed. So the network continuously learns and adapts. So this closed loop architecture is what that enables the modern network to become autonomous, and maybe you can call it as a self-optimizing uh, network communication. Okay. So in many ways, this resembles the human nervous system, right? So the sensors collect information, the brain processes the information, and our body performs the actions. So you can relate to that. Similarly, our intelligent networks are continuously sensing, thinking, and acting. The actions are being taken. Okay. Now coming to the next topic is that one of the most important technology shift that is happening today is the movement from centralized processing towards the edge processing. Okay, so the edge analytics. So traditionally, data generated by the devices was transmitted to a cloud server. As I started by telling you that information will be saved in the cloud. So while this approach works in many situations, it introduces latency. Yes, we know that information has to be fetched from the cloud and to be brought to the edge or the device, then we process it and we have to update it again into the cloud. It is very complex. Okay, so this is where your edge analytics becomes important. Actually, the idea is very simple. Okay, the person who have invented is very not that brainy, but we could have done that. The idea is very simple. Instead of sending all data to the distant cloud server, processing is performed closer where the data is generated or the where the data is saved. This could be at the base station, an edge server, or if you are considering the transportation system, the roadside unit, an embedded device. You can have it in the traffic islands, okay, or even in the device itself. So there are several advantages to this approach. So first advantage, you can call it as the latency is reduced. It will be significantly reduced. You can assure on that. So the decision can be made much faster. And the second one is the transportation. How transportation in the sense how the data is being transported, bandwidth consumption. Okay, so that bandwidth consumption decreases because not all raw data needs to be transmitted across the network. Okay, only the learned parameters will only be transmitted to the cloud. Okay, the third advantage is that the privacy. Yes, we have discussed enough. And the fourth one is reliability. So the reliability improves because the local processing, it can continue even when connectivity to the cloud is limited. We are not considering the connectivity there. Okay, so these are the advantage of edge analytics. It enables enables the decisions or the analytics by performing critical computation close to the device or the vehicles or the devices, whatever, wherever you are having it. So as future networks move towards our maybe ultra low latency, that is what we are foreseeing to achieve. So ultra low latency applications. So our edge analytics will become a fundamental architectural component. Okay. So the example noted here is an autonomous vehicle decision making. You can think about it, how our edge analytics is going to work in that case. Okay. Now let us discuss one of the most exciting concept in intelligent systems, that is our digital twins. I am also telling that term a lot in our sessions. So a digital twin is essentially a virtual replica of our physical system, as we have discussed. Okay, so imagine creating a digital copy of the city that you are living, not just the buildings and the roads, but also the communication towers, the traffic system, sensors, power infrastructure, and even the user movement patterns you can include in your digital twin. So this virtual representation is continuously receiving several real-time information from the physical environment. So as a result, the digital twin remains synchronized with the reality. So why you need that such a digital twin? It is a twin of our city. So why we need that? Because it allows us to experiment without affecting the real system, which is also known as shadowing. Without exposing the entire solution to the real world, if everything is coming, we can actually experiment our solutions. Okay. So for example, suppose a telecom operator wants to deploy a new communication tower. Assume that scenario. So rather than physically installing it and hoping for the best, what he could have done if we were having a digital twin? He can evaluate the coverages. He can the inferences can be analyzed, the performance can be predicted, and then only if he is satisfied, he can have that he can prepare accordingly and he can install that tower. Okay, so the digital twins can also support the predictive maintenance. So if a component begins exhibiting unusual behavior, the simulations can estimate its remaining useful life. Okay, so there are equations to calculate remaining useful lifetime, and recommend corrective actions from the simulation itself. That is the benefit of having a digital twin. So as the computing power and the sensor availability, it continues to increase. So our digital twins are expected to become, you can call them as a cornerstone of future intelligence. Okay, so that is the importance of our digital twins. So here I have given you a few high impact use cases, such as connected autonomous vehicles, which we have discussed a lot in throughout this session, and the disaster responses, the smart agriculture. Everything is will be beneficial uh, with our next gen communication system, having a digital twin to help it with. So how it is been helpful in our intelligent transportation system, with the dynamic traffic routing, the smart traffic signals, and obviously the emergency vehicle prioritization. Why it is the most critical thing is that you look into it, because we are seeing that a lot in our newspapers and in our TV and whatever media that we are having. They're telling that an accident happened and this is the fatality. So what is happening? That may be due to, actually the studies are telling that 95% of the fatality happens because the medical helps are not provided within the time. So we are not getting notified of those accidents. Okay, so wherever that emergency help is needed, we can't provide that, even though we have that infrastructure to provide. So this simulation analysis and the continuous monitoring of the system will help us to solve that particular problem. The route optimizations, the connected vehicles, everything will be benefited, and which will lead us to the smart city applications, and obviously the disaster management. Hope you remember the flood that happened during 2018. What all things that we could have achieved if we were in this particular era of intelligent communication? We could have predicted the flood. We could have planned the rescue routes in a better way. The resources can be allocated in a, if we were having a route planning, or at least we could have a early warning system. Okay, at least. Okay, the flood happened. Then the post disaster assessment could have been done in an easier way. So these are the excellent examples of that technology can help us in our future research aspects. Okay, so having explored the current application, let us now look into the future application. So several exciting research directions are there. That is intersections of AI, geospatial intelligence, and networking. The first one is autonomous self-healing networks, as we are hoping for to achieve today or tomorrow. So today networks can identify the faults and recommend the solutions, and they can anticipate it. We are very much hoping for a self-healing networks. The future networks will be capable of automatically diagnosing, correcting, and optimizing themselves without the human intervention. And the second area is geo AI driven decision systems. Okay, so the future systems will be continuously combining the spatial data, real-time observations, and predictive analytics to support the intelligent decisions across the domains. And the third one is our digital twin based network optimization, which we have discussed. So these opportunities for innovation in this field are enormous actually. So for students, researchers who are actively contributing or wanted to contribute into these areas, um, they they have maybe there are numerous possibilities for impactful interdisciplinary research. Okay, now, what are the emerging technologies? Most of these we have discussed. The first one is 5G, and eventually we are transforming into the 6G networks and will be providing the communication foundations required for a massive scale. Why we are moving? It is because of the scalability factor and the connectivity factor. And obviously, the point not to be forgot is the ultra low latency services. The second one is our edge AI, and the third one is our UAV assisted networking, that is gaining a significant attention today. That is drones. By telling the UAV, you might be wondering what is it. Actually, it is a drone. You are we are starting we are started using that from our corona time. Okay, that can function as a communication relays, temporary base stations, maybe an environmental monitoring platforms, and data collection systems. Okay, then the digital twins, which we have discussed enough with, and then our autonomous system. Then yes, our large language models, LLMs, those who have some fundamental idea of natural language processing might be knowing what is a large language model is. And imagine querying a complex network infrastructure using natural language, or asking an intelligent system to summarize network performance. You'll be getting a report of that. That is why the LLMs are used for, to identify the anomalies. You give a report on these things. So these capabilities are becoming increasingly feasible. Okay, so the convergence of these technologies will define our future landscape of intelligence system. Okay, so there are a lot of research challenges like data heterogeneity and scalability, privacy concerns. The heterogeneity is always a problem. Okay, so these are the open research challenges that we have in this particular area, and there are ethical and security challenges as well. So we have to be taken care of the privacy of mobility data and surveillance concerns. And there is a very big challenge in AI models, that is the bias. So how to mitigate the bias and fairness in the AI models is a very big questions yesterday, today, and obviously will be for tomorrow, which is dependent on your problem or application uh, to be done. And then the data governance, so cyber security risks, these are also your research perspective where you can achieve into or explore more into when you are moving towards the communication, intelligent communication systems. And with this let us briefly summarize the journey of our session today, or the sixth session of this FDP. So, we started by understanding the evolution of communication networks from simple connectivity. They were focused systems to intelligence, adaptive, and autonomous infrastructure. Then we then explored the three pillars that enabled this transformation, that is our AI and geospatial information and analytics. And we discussed how AI is enabling the prediction, automation, and optimization. Then how we have discussed how our GIS and special intelligence is providing the context through the location awareness. And then we have discussed how the analytics, edge analytics in specific, are converting this raw information into our actionable insights. And then we have looked into the architecture of the system. Then we have understood the various research perspective of this particular area. And yes, looking ahead, our future network will increasingly becomes autonomous. Okay, so they will be continuingly or continuously learn from data. We hope that they will understand the environment and predict future event and optimize their own operation. Okay, so the future network is actually not merely a communication platform. We are incorporating or we are injecting some intelligence to have an intelligent decision making ecosystem. We are hoping for that. Okay, so before I conclude, I would like to leave a note or a final thought that our next generation of networks will not just connect the people. They will map, they will understand, and they will optimize the physical world in real. Okay, so in many ways, the future networks will function as a intelligent nervous system of our digital society. So the convergence of AI, geospatial intelligence, and analytics. You have to always remember the three pillars of our next generation communication. I hope that these informations were useful. And with this, I would like to conclude this session. And I would like to thank you all for your patient listening.
Thank you, ma'am, for this wonderful session. Now
Yes.
the platform is open for participants. If there is any questions, you can post it on the chat box so that ma'am can answer.
One question I am seeing in the chat box is what research opportunities exist at the intersection of AI, communication networks, and geospatial? Yes, that we have. I think that we have discussed, right? Right. So if you are from a security background, like a cyber security kind of things, also you can look into the ethical and security challenges. And another open research challenges are the scalability and the privacy concern and the data heterogeneity. How to, while combining these things, how you are going to move into, how you are going to achieve these things, how you are going to process. So once you have established the model, so how that scalability is going to affect. So processing these gigabytes of data per second without draining the network energy is surely a research problem that you can solve. These are the research perspective under this. Yeah, thank you. I hope that answers that question.
Okay, ma'am. Thank you. I think we can wind up the session now.
Okay, ma'am.
On the behalf of Department of Electronics and Communication Engineering of Jyoti Engineering College, and on behalf of our participants, I extend heartfelt gratitude to Shindu ma'am for this truly enriching session. Thank you, ma'am, for a lucid and well-structured session, weaving together AI, geospatial data, and advanced analytics into a coherent framework of next generation intelligent networks. So it looked so effortless and much clear. Thank you, ma'am, for sharing your time with us.
Thank you, ma'am. Thank you for actually the opportunity that you have been taken time to invite me and giving me such an opportunity. Actually, these are just introduction. I know that, but if anybody is more interested to the most interested to discuss more on any of these, I'm always open for a discussion, even through the mail or any other communication that is available. You can take it from the coordinator. And thank you for that opportunity, ma'am. And sir, Prajun sir. Yes.
We wish you the very best in all your future endeavors, and we hope to have the privilege to your presence in another sessions if possible. Thank you, ma'am.
Yeah, thank you, ma'am. Thank you. So I'll be leaving the session. Thank you all.
Thank you. Dear participants, this is the end of today's sessions. We hope you found today's program insightful and engaging. Tomorrow's session will commence at 10:30 a.m. and